Okay, I think that's it. I think we've had enough people here. Good evening, everyone. How is your week so far? My name is Adani, but you can also call me Dani as well for short. Today, I'm going to be your moderator in the 8th edition of Agile Ambition. So I hope everyone is having a terrific week because today we're going to talk and discuss many things about design patterns. Okay, so please get comfortable in your seats and we also will have Q&A session later. So if you have any question during our discussion, feel free to pop your question into the Q&A section on the bottom side of Zoom. Right. So without further ado, now let's get to know our speakers. Okay. So let's see here. We have 3 speakers. Perhaps we can get started with Alfiana.
All right. Hello, everyone. Let me introduce myself. My name is Alfiana Siwe, but you can call me Fian. I'm the lead engineer in the Mekari. And yeah, I think that's it. Yeah. Okay.
All right. Okay. Thank you, Fian. And then we also have San as well.
Okay. Hi, everyone. I'm Sans. I'm working as software engineer at Startup Studio in Money Forward. So basically, Startup Studio is kind of an incubator. So, our CEO gave us some money and said, take the money and build the product. And I have been working for Money Forward for 3 years, from real engineer to blockchain engineer, and joined to microservice team to, build an internal microservice, and now set up in Startup Studio. So yeah, nice to meet you guys.
All right. Okay, thank you, Sans. Now we also have Duke as well here.
Okay. Hi, everyone. And thank Mekari for inviting me to this interesting discussion panel. My name is Duke, lead SIE at Money Forward. I'm happy to be here tonight, and I hope I can share some of my experience from my guide of using design pattern.
All right, cool. All right, now that we've introduced ourselves, then let's get started. I think today's topic is about design pattern. So for those that have been in tech and engineering for some time, design pattern must not sound so alien, right? But I think some of us might not be quite that familiar with it yet. So now my questions for the speaker. So what is exactly a design pattern, and where does a design pattern come from? Okay, well, perhaps we can start with San.
Okay. For me, a design pattern is a set of principles or rules or best practice to solve the problem or issue of software engineering, and it corresponds to solve the engineering problems. So of course, it comes from software engineer, right? So actually, like if we have any problems and if we can provide a good enough solutions for the problems, and we can create our own design pattern as well, and other engineers can also use our patterns. And yeah, just I think what is design pattern, and yeah. Can I answer your questions?
Sure, but I would like to hear from others as well, right? Okay,
Yeah.
perhaps Fian, you would like to voice your opinion as well?
Yeah, I'm just like extending what San said, right? It's just a design pattern is just like a principle that can be used many times. It's reusable. You can apply it in multiple component in your system, right? And I think this is just like my opinion, right? I think it's come from the needs that sometimes we need to produce a solution that reusable to a common problem, like which in the environment where we are working with a lot of engineer or like more than one engineer, where they need to understand the system well.
All right, got it. Duke, what about you?
Okay, I agree with you guys. And well, design pattern a general solution to solve a commonly occurring problem in software design. So when someone found an excellent way to solve a problem, they will say to another with a good document. So as software engineer involve many new problems involved, as well as many new design patterns are also created.
Got it. Okay, so basically it comes from people's need, to solve a very common problem in engineering, yeah, in this case. And well, as many kinds of problem appears, so does the engineering design pattern as well, right? And yeah, there could be many design patterns for a single problem that we want to solve, right? So that's basically it, yeah. Okay, but you see, some software professionals, perhaps some of them does not really see the value and benefits of using design patterns to the software development process. So from your experience, what are the most significant benefits of design pattern? Okay, perhaps Duke, you want to answer that?
Yeah. Okay, so with first opinion, I think I have agree with it and have disagree with it. Well, I prefer to keep it simple as possible, so I don't think we should think so much about design pattern unless we know exactly what problem we will have. Because if we use a design pattern for the wrong problem, it might become an anti-pattern and make our software become much more unnecessarily complex. On the other hand, if we use design pattern for the correct problem, the most benefit is solving our problem in a proven solution. So we will not be likely to be forced to refactor lately. Another benefit is design pattern can reduce communication time. As Manifold is a global company, we have many people from around the world. So the cost of communication is much higher than normal company. Suppose one member of my teammate are familiar with the design pattern. In that case, we can more easily communicate with one another about potential solution to a given problem without explaining it from scratch.
All right. So basically, the biggest benefit that you feel that you get from applying design pattern is you will have a common language, yeah, with your fellow teammates. It is communication a lot in that case. All right. Now, what about you, San? Would you like to add to that?
Okay, I have to agree with Duke some points because I'm Vietnamese and I'm working at Japan, right? And actually, like design pattern can improve the effectiveness of communication, right? Especially in the global community such as Money Forward. Our engineers from Vietnam, Taiwan, China, German, even Africa. So and of course there is a language barrier between like a lot of people. So coding and patterns could be so like common language among engineers. Like for example, instead of saying like I'm gonna create an instance of a class, with only illustrate once, actually I can say that I'm gonna use singular pattern, right? So it's much easier to talk and understand between the engineer, right? And other benefits, I think many people will say that design pattern can make the code easier to read and maintain and test at the coding level, and I think that's true. And I think other speaker will talk about it later on. And a lot of people think about design pattern at the coding level, right? We have like singleton, decorator, factory, OOB, but if we apply the design pattern as a higher level of software engineering, socket architectures or like database layer. So we even can improve the performance of our system as well. So yeah, that's what I want to add.
Oh, all right. Now, what about you, Fian? I know that you and I work together at Mekari, and we've been using a lot of design patterns, but what is the most beneficial, well, the most significant benefits, that you get from applying design patterns into our code?
Yeah, I think what we are like, it has been explained by Sun and Doug also, like just in terms like, it's easier for us to communicate with other engineer if we have a set of design pattern that we apply. But it's kind of like interesting, like if we as like maybe all of you guys like first time engineer, right? First time software engineer, and you hear like design pattern, it's kind of like something that is probably really hard, right? But apparently, like believe it or not, like when you, for example, in my experience in the backend engineering, which mostly working on the web framework, if you take a look or if you develop something in using web framework, you usually like already doing the design pattern that has been set by that framework, right? For example, like maybe the simple one is the model view controller. It's one of them, right? Because like there's a lot of design pattern, and design pattern can be anywhere, right? Can be in the database, and the architecture can be in the back end, or even in the front end if you develop something in, for example, single page application, right? And yeah, that's maybe like design pattern itself, like most of us is just like actually already using it. We just didn't realize it as much, right? I think yeah, back to the point, what the benefit it's already covered with Sun and Doug is if when you're working in the team of the engineer, it's help us to develop and communicate when you have set of design pattern, and it could also improve the productivity of the engineer. And some design pattern, if that implemented correctly, it could also bring improvement in the performance and in the system that we built. I think that's it.
Okay, right. So it's very interesting. So basically, what you guys have been saying, the benefit consists of easier collaboration and communication with your fellow teammates, and then our system can improve in performance and maintainability as well. Yeah, because of that, because of using a design pattern. All right. Now, so at the end of the day, design pattern is just a tool, right? Basically, if you want to work on something, there are a multitude of tools that you can use, to solve that problem. You want to put a nail on the wall. Well, you can either like bring a rock, or you can use a hammer, or even use sledgehammer. The bigger one, right? And just like that, problems in engineering can also have multiple solutions as well, right? And one of such solution is the usage of design pattern. So I would like to explore, based on your experience, right? What are some common problems that you guys usually encounter, and how do you determine which design pattern to use for this kind of problem? Okay. So perhaps we can start with Fian, yeah.
Okay, yeah. In my experience, I usually face a question, right, when we are trying to develop a new service or a new system in the company, right? How do we, what design pattern that we use, right? That's usually the common problem at when you face in the very beginning of the development of the service, right? And for myself, I think when you there's several things that we can ask, like a question that we can ask when we are deciding this design pattern itself, right? Because like you can, I think you can apply a lot of any design pattern to any problem that you're facing in any service, right? It's because it's very flexible, but sometimes in the very question, the first question is just like, what the programming language that you use? Because in my experience, like there's some language that make us easier to implement certain design pattern because they like built on top of it. If you see the JavaScript, they have the prototype design pattern, and which allows you to extend like a prototype some kind of like class or instance, right? In Ruby, for example, is much more like class-based or object-oriented, right? But that doesn't mean that you only able to use that defined design pattern using that programming language. You can still use any design pattern using that programming language. It's just like take much more effort to set up, and probably there's some kind of like library that already out there that help you to implement that. So that the first is the programming language for me, and the second is like how do we able to test that design pattern, the testability of the design pattern. How do we able to come up with the system that use the design pattern that also easy to test, because we need to make sure that what we have built is testable. It makes sure that if we change something, we didn't broke another. That's the main point of the testability. And the third one is the performance itself. Like because like the design pattern can affect the performance, because like and you should like choose the correct one when you trying to match this thing, right? The programming language and the performance and design pattern, just to make sure that when you apply something, you apply correctly, or when you apply the design pattern, it doesn't make the performance that the system that you built worse, right? I think that's the 3 points from me.
Got it. Okay. Perhaps I would like to know your opinion. Yeah. What about you, Dirk? You want to add to that? Mm-hmm.
Okay. With me, I really agree with Fanny about, well, if we use framework, then maybe it's already implement some design pattern, and in that case, we should not reinvent the way and just use it. And each solution usually comes with some trade-off, so I will consider what trade-off I can accept when choose a solution. For example, one design pattern may create my code very complex because it's so very complex problem. But my problem is not that complex, it is a simple problem. So I will choose a more simple solution to solve it. Or it can be implemented in a good performance way. Can it make my software run fast, or it will just because readability, it will decrease my software. And the most important maybe how long that my team can implement it. So with new engineer, maybe too complicated solution may make it very hard to implement, and we cannot do it in time.
Okay. So it's basically you will need to gauge the trade-off, right, between the multiple design patterns that is available, to solve that single solution. And basically, yeah, you think about that, yeah, how easy it is to implement. Is it good in a performance way? Yeah, does it make your software easier to read? Basically, yeah. Okay, cool. Now, San, what about you?
Yeah, Dirk already said that every solution has a trade-off, and one of the things I learned in software engineering and computer science that every decision should decide based on the context. So for example, the resource team or like the team ability, the business, everything like that. And back to the question of Danny, what's the question and what's the
So the question, yeah, about common problem that you guys usually face, and how do you determine which design pattern that you would use?
Okay. Talk based on my experience. For the previous project, I have problem about handling the time-consuming tasks. Such as generating file or scraping web, and the problem about decoupling the service. Like you have like two service and you don't want to like service A call to service B, service B to call to service A. So yeah, the problem about decoupling the service, and I have used a pub/sub button for that this type of problem. So based on my experience that when we want to determine which button we should use, so the first we should understand the root cause of the problem, right? Because the design button was want to solve the problem, right? And after understanding the root cause of the problem, if you don't have any experience about that problem, you should search on internet or ask senior engineers, and then based on the based on the context of the team, for example, we want to release a feature faster, so we should choose a simpler solution without using the design button or something like that. So yeah, is that good? Can I answer the question?
Yeah, sure. Let me confirm. So basically, you need to understand the root of the problem itself, right?
Yeah.
This thing is that what you need to do. And the next one is you would have to like research basically, on what's the trade-off of using a particular design pattern. Does this kind of problem is suitable to be solved with this design pattern or not? And basically, considering the trade-off, if you want to deliver it quick, you probably wouldn't want to pick a design pattern that is too complex, and takes time to implement. Yeah.
Okay.
Oh, right. It's been very interesting so far. Can you guys give me some real life examples, of design patterns that you have implemented, and what's the impact to the product that you're working on? Okay, perhaps Sam, you would like to start with yours?
Okay. So actually, when people talk about design pattern, right, a lot of people think about like singleton, factory, decorator, builder, observer, some OLB design pattern. But as I said before, that design pattern was born to solve the engineering problem, right? And the software is always involved, right? So 30 years ago, a problem is totally different with like today's problem, right? Like 30 years ago, people used a lot of OLB, and then the software engineering problem come, and the new pattern will come, and that's for sure. And actually, in my recent project, like just 1 month ago, like we have a big discussion about should we adopt the single table pattern in NoSQL. So basically, we have the two solutions. The first go with the relational DB, such as like MySQL or like PostgreSQL, and other solution is come with NoSQL with a single table pattern. So so eventually, I made a decision to choose a single table pattern. Like for example, in MySQL we have the import user and commonly table, and you have the user commonly to actually in relational DB, we usually use the normalization, like 1NF, 2NF, and 3NF to design the database, right? But the problem is when you want to get data, you usually need to join many tables to to get the information you want, right? For example, in this case, actually this is based on my real product that I'm working on. But so basically, for example, you want to get the role of user in the company, you have to join the user company and user company table, right? So I guess you guys have experience with SQL, right? And
so
the problem
you have
is
to join everything, right?
yeah, exactly. Okay. So problem is when the amount of data is huge. I mean, we have like millions of user, millions of company, million records of user company. You have to write everything to get the information you want. So that's very cost. So join query in MySQL is very cost, and it takes a lot of time to select the information you want. And just like 2 or 3 years ago, the new button was come, I guess. It's called single table button. So basically, you put like all of the database in a single table. So that's how stupid, right? Right? Like for example, you have like 20 entities or 100 entities. You just put it in the single table. But the benefit is the query is very fast because you just look up at the single table. And like for example, I point here. First of all, you want to get the role of the user one in Mekari. In Manifold, he is director, but in Mekari, he's an engineer. So if you want to get information, you just only need to one query, and you get what you want. So that's a button that I'm using as a product that I'm working on. So my point is because software is always involved, like because of thanks to the popularity of OLP, the singleton decorator, some button has been around us for many years. But when software is involved, right, so new problem comes, and of course the new button will comes to solve that problem. And now, for example, my problem in my project, that's data. So data will be huge. So that's why I decided to choose a single table button for my project. So, okay.
So I guess it's not for every kind of project, right? Like
yeah, exactly.
Very specific,
yeah. So very specific project. So yeah. So yeah, as I just said, as Dick says that every solution is a trade-off, right? You need to make a decision based on the context of the team, the business. Actually, in my project, in my team, no one have experience with NoSQL, so it's kind of like difficult to. I mean, we have like 3 engineers, and 3 guys have only experience with MySQL without any expertise in NoSQL. But eventually, we decide to switch to the single table buttons.
Very, very interesting. Okay, thank you, San. So I would like to explore answer from Duke now. So Duke, what is some real life examples of a problem that you face, and the design pattern that you've implemented for the product that you've been working on?
Okay. Yes, so I am SIE, and many people think us SIE do not like coding very well. They just do some config. Actually, we implement some software to automate our operation, and this is one of examples. So let's see. We just we create a software to process or log and output in many formats like YAM or JSON or maybe plain text. So I use dependency injection and strategy pattern to isolate the log processor and output process to different classes. So we can easily insert new formats for output processor, or we can edit log processor without breaking a program. Okay, so
yeah. So dependency injection. This one is pretty. I think it's pretty common and adopted in wide range of engineering problem. It's basically just it's basically like a inversion of control. Right?
yeah.
And it enables you to decouples and separate the concerns on, for example, this one is the output processor for the YAML format and the JSON format and the log processor itself, right?
Yeah.
Awesome, right?
So I have a question for Duke. I mean,
Okay.
I mean, this is just for like you just handle the 2 file format, right? I mean, you actually just like using if else and without using any button here. I mean, just totally fine. I mean,
Okay, but now we support 2 formats, but I don't know in the future it will be how many formats we support. Since we use my tool with many other tools, so maybe future it will be Tom, maybe plain text, maybe who knows new format maybe. So if we use if else, then it will be very difficult to edit our code, and it will be very difficult to test.
okay.
So, well, I'm the moderator, but I think I understand this, yeah. So basically, what Duke is creating here is a log processor that can accept output processor of any format, right? Like, so the dependency injection is injecting the dependency of output processor into log processor itself. Am I right, Duke?
Yeah,
I
actually.
see. Okay. Yeah. It's a very simple example of dependency injection, actually. Okay. Anything to add, Sun?
Actually, I mean, no offense, but I mean the automations, the code base of automation tool is not really large, right? So do you like because of the code base is very small in automation tool, especially for the internal tools. So so do you see any like trade-off of using like design pattern into like small project? Like for
Yeah.
the automation tool for the like internal tool. So
Yes. So with small tool, we should not use more complicated solution. But with dependency injection and strategic pattern, it actually don't add very complex to my software. So in here you can see I use if else to create my output processor. Actually I can use other solution like builder or factory, but it is not needed here.
okay, I see. Thank you.
All right. So I think we haven't heard from Fian, yeah. Fian, what about you? Yeah. So what have you been working on? I mean, what design pattern have you been using lately, and what impacts to the product that you've been working on?
Yeah. this is just like the recent thing that we developed. We developed some kind like, so the problem is just like we want to have the proper functionality when we are tracking the user activity, like login or register or something, right? What we're doing on our service. So what we have built here is some kind of like a adapter pattern, where basically we have some kind of like a class, analytic class that provide a method, a simple method that can be called by any class or any instance in the code base, which allow to track, allow to send a tracking event to multiple data storage. If you see here, like in the adapter pattern, we some kind like implements an adapter which allow us to convert the track interface into the proper interface based on the target data storage that we want to deliver, the data we want to deliver. For example, if you see this, there's a completely 3 different interface. For example, the service SDK. This is probably like, imagine when you send something to the some kind like data storage, but it's software as service that provide the data tracking, for example, right? They provide some kind like software development kit, but the interface is different, right? If you do conventionally without adapter pattern, it means that in that some class you need to call like service a record, like also save an active record. By the way, the active record is object relation manager mapper for the Ruby and Rails. And also there's an API call, right? If you didn't use the adapter pattern, you call all of it in your sum class, right? Which is like, it's terrible. So we implement some kind of like adapter, which allow us again to convert the data that some class want to send, the tracking event, to the proper SDK, for example, or like convert it into the create method on the active record, or even convert it into the HTTP call. The Faraday is kind of like HTTP library in Ruby. As you know, maybe it's there's other HTTP library, but in Ruby there's a Faraday. So this kind of like adapter pattern allow us to, for example, if we want to plug another data storage, for example, if we want to save it in like Google, I don't know if Google have like tracking event. Just imagine that there's a Google Cloud storage or a Google Cloud tracking event in the new service. If we want to use that, we can just create a new adapter for that. And if you guys see on the arrow, the split tree arrow, we also have a configuration which like some kind of like a toggle that determine like should we enable tracking to the service A, or should we enable database tracking, or should we enable the API, example API tracking, for example. This toggle is allow us to like dynamically change the event storage on demand, right? So it's not like we don't have to change in the code, but we just change it into in a database configuration. So this is the adapter pattern that my team recently built.
Okay, so it's basically an abstraction, right?
Yeah.
So basically the caller, yeah, the SOM class call does not really care about what kind of interface that is being used to call a particular storage service. Okay, cool. Okay, Duke or San, do you have a comment in this kind of pattern? Or,
yeah. Well, I see you not only you adapt the pattern, but also singleton pattern here, like analytic to track.
Yeah.
So or
So
is
his question is, do you use singleton pattern in this implementations?
No, I think there is no singleton pattern because this is just like, so if you see the adapter itself, it's not outside of the analytic class. It's just like the inside of the analytic class, and we use the some kind of like async processor to trigger multiple adapter at once when the track method or track interface is called by the sum class, for example.
So as I see here that checking.create is a static function, right? And you probably didn't like pass the object into analytics class by just calling the static function from checking or Faraday or service A, right? So like, did you consider using like dependency injection such as Duke already used before, by bypass the object into constructor instead of like calling the static function from like checking Faraday and service A? So yeah, user says that there are a lot of flexible of using like design pattern, right? So
yeah, I agree. Like so just for the background, what I'm writing here is not exactly what we are implement. I'm just
okay.
put the easy things to understand, because like if you see a class and dot and the method, you can like understand. But yeah, again, if you take a look at the design pattern itself, like it's very flexible that we even can combine two design pattern into one, right? There's no limit. Like I'm not sure if we can combine 3 or more, but mostly in my experience, we can combine two design pattern. For example, it could be like adapter pattern, and like inside of the adapter itself, we can like just like some say is like we can just put another design pattern on that. So yeah, I think that's the beauty of design pattern, right? We can just mixing together, use anything that we like, or maybe it's we think it's probably giving a better performance to our code base. I think that's it.
Yeah, just like you can like build or well, build a house with multiple tools, right?
Yeah.
You can use multiple design patterns.
Yeah,
That's a cool insight. Yeah. All right. I think we've been discussing long enough. Yeah. We've eaten more than half of our allotted time. Now, I think it's a good time to take on questions from the audience. Okay. Seems like on the Q&A Zoom, we already have 5 questions. All right. Let's see. The first one from Vincent Lius. What programming language does Mekari use for software engineer? Is it Kotlin, Xamarin, or other? And is it possible if a company use different software engineering language? Okay, this one's probably not very related to design pattern, but we will answer it anyway. Okay, Fian, I think this goes to you, yeah?
Okay. Well, if I can call correctly, because I'm like one of the team in many engineers in the Mekari. Mostly Mekari using Ruby, and we also use Java. I think there's also PHP and Golang. And yeah, I think that's the main 3 if I can recall, like Ruby, Java, PHP, and Golang. And it's of like the decision to choose this is probably is because I'm not sure why they choose this, but probably this is because like they need specific things, specific programming language to solve their own problem in their team, right? But mostly in my team, we are using Ruby and in the Ruby on Rails as the framework.
Okay, got it. So it's possible, right, for a company to use a different software engineering language.
That's
right?
possible.
Okay, cool. I hope that answers your question, Vincent. So next question, what are some commonly used design patterns and the trade-off when using them? From VHD. So who wants to answer this first? San, you probably interested to tackle this one?
What are some common used design pattern? Okay. I think it's very depend on what is the role. If you are doing the OOP, like some patterns such as a decorator or like singleton could be the common use. Like if you are like Rails engineer, you probably use decorator pattern from like wrapper. And if you are front-end engineer, especially like Vue.js or something like that, you probably use the observer pattern, like from ReactJS or reactive programming, and yeah, I think it's really depend on what you are doing in the software engineering, because each field will require a different kind of patterns. Like if you are doing the functional programming, you probably will not use some OOP pattern, right? So yeah, and the trade-off when using some, I think other speaker already said that the trade-off maybe is it could be the over engineering or overkill. I mean, we use a complex complex solution for the simple problem. Like for example, the demo from Duke, I mean, he just only handles the two format file, right? And he used like dependency injection and strategy pattern. I mean, if I handle that code, I mean, I probably just use if else, right? If the format is JSON, if format is Jam, so I will handle it, I will handle that without using any design pattern at all. So yeah, I think it's the biggest gist of that. Yeah, we will add a new complexity in our problem. So yeah, that's my answer.
Okay. Fian or Duke, you wanna say something?
Okay. So first, what are some commonly used design patterns? So I can list here some of my experience. It may be singleton, or builder, or observer. So the most commonly used design pattern was singleton, I think. So with singleton, it will help you write fast, so you can just use it. You don't need to initial it, and it may be speed very fast. But if you use it for like an object and you code it only one time, then you never code it again, then it will make your memory being waste. So it's an example of the trade-off of design pattern.
All right. Cool.
I see the Kian comment here that he said that single responsibility principle could be the like most common use pattern. Yeah, I think that's true. I mean, it's not only the pattern, it's the like idea of designing software. Like it's not only the coding level, but also the infrastructure as well. Like when you do the microservice, you probably want to create a service that only do one thing, right?
Mhm.
Like for example, the microservice for authentication, microservice for generating PDF, a microservice for for checkout, something like that. So I think yeah, that could be one of the patterns that yeah, I would vote for this.
Yeah, it's just very fundamental, yeah. Like
Yeah, it's a very fundamental thing that can be applied in everywhere. So
okay, we'll go to the next question, yeah. Hope that answers your question, VHD. Okay, from Tuan Nguyen Ant. Do you guys think we should also learn anti-patterns? Wow, what an interesting question. Learning anti-patterns, who would have thought? So, anyone want to answer that?
Yeah, I think
Okay.
we should. I think we like it's not a lot. It's just like you learn good thing, but you also need to learn a bad thing. So when you see that bad thing, you know that's bad, right?
Mhm.
It's just like giving you idea what is kind of like anti-pattern, what is kind of like a design pattern. So if you ask that should we also learn, then yeah, you should. I think it's not should, you must learn it.
Mhm. Okay. Anybody want to add to Fian's opinion?
Okay,
Yeah.
yeah, I think I agree with Fian, but actually I don't have much experience with anti-patterns. I just know only the God class. I mean, so the pattern that a class can handle anything. The kind is opposite with the single responsibility principle.
Indeed.
So actually actually anti-pattern should be like nice to have, not so like must to have knowledge, I think, because most of the time we know we need design pattern when we realize that the output and our system is kind of messy. So at that time we probably realize that we need design pattern. So I think anti-design pattern is nice to have knowledge, not like must to have knowledge. But definitely, if you want to learn, just learn it. So okay.
Actually, I think we can learn anti-pattern from our old course, our legacy code, so we can understand why it's best and like make a better approach.
Okay. You imply that we've already been doing anti-pattern all this time. We haven't just been aware of it.
Probably,
Yeah.
Okay, cool. Right. Hope that answers your question, Tuan. Okay, next one from Nguyen Mint. How did you learn design pattern? I know there is a book called Design Pattern, but it's too long and challenging for everyone to read the whole book. Do you have some advice for a young engineer? Okay. Any one of you want to answer this one?
Okay. Well, I I actually think learn design pattern from book it may be hard. So actually, you don't need to learn every design pattern. You can read some commonly designed pattern, and you should like try implement it, not in product but some like example code, so you can understand what is so and what trade-off of it.
Okay, so learn by doing and
Yeah.
experience basically. Okay, cool. Any other tips from San or Fian probably?
I think from myself, I only like know like 5 of design pattern, honestly. But if you Google it, there's a lot. Like recently before this webinar, I can like research right about design pattern because I only know 5, right? And like there's actually a lot. Like there is a site that show like there is a 23 design pattern, but most in your later in your professional experience, you probably just use like at least 3, right? Or maybe 4 if you have another experience like if you already work in a couple of companies, it may be growing, but usually in when we are work on the team, we only know once, but it's good for us to know that there's a couple design pattern because it's allow us to like thinking that can we improve performance if we change the design pattern into like observer, for example, like can we change improve something if we change it into singleton, right? This is just, but again, if you don't like read a book like me, you you can just like probably browsing an article. But if you really like to read the book, then read it. But sometimes I know like it's not the book itself is like probably less too complicated to understand, right? But again, maybe you just should know like 1 or 3 or like 4 like big, and then like goes along with your experience, you will get more design pattern, and who knows, like there is probably a new design pattern will be coming in by the end of this year, right? Which because this like just like keep expanding it and it will never stop.
All right, cool.
Okay, yeah, I want to add something. Recently I'm learned about cooking, and I discovered that the common thing between the cooking and software engineering, when you want to make a ramen is a very famous Japanese noodle. If you don't have any experience about cooking ramen, so you probably end up with a like terrible ramen pro. So the idea is that you should follow the recipe, right? Because if you have no experience about cooking and you just cook, you probably end up with a terrible food. So you should follow the recipe, and I think the idea is the same with software engineering. Like we just code without knowing what we will do. So if we properly will be messy, right? So like design pattern is kind of like the recipe in cooking, right? As is my opinion. So the point is that you cannot learn how to cook the best ramen, how to cook the best sushi. That is not how you can be a master chef, right? And you probably like the same idea is the same with design pattern. You cannot like, search own design pattern and learn it, right? It's impossible. Like you want to cook the best ramen, best sushi, and you just learn it. The idea is when you face the problem, you start researching and start learning new design patterns. That's how I think it works. Not like buy a book with like 24 patterns and read it and we probably will not use it. Like some pattern like iterator, like common, I have not used like in my entire life. So basically my answer is that you should do more, and if you face to any problem, you start research that what kind of problem I am facing, and searching for solution for that problem, and probably yeah, you can meet a new design pattern. Yeah, it's based on my experience from the previous project about like single table pattern. So actually I have not heard about it before, so yeah, that's my answer. So okay.
Cool. I think that would be very helpful to the young engineers. Okay, thank you. Okay, next question from Ahmad Leo Yudanto. When two smartest developer in the team have different way to do design pattern, how do we decide which one to use? Spicy.
Yeah, this is very interesting question, right? Like if you have a two smartest people, like they probably like, okay, I like this design pattern, and like the other person said that no, I don't like that, and I like mine, right? For me, we could have some kind of like a meeting where if this really happened, we should set up a meeting where we compare the idea of these two smartest developer objectively, considering like what is the advantage of like his choice, like, right? So because yeah, again, this is not technical problem, probably this is just like a people problem that need to be talk about it. Like probably it's better in the meeting or in like something like that. That's from me.
Anybody would like to add to Fian's opinion?
Yeah, I think it's more about like people problem than engineering problem. Yeah, but yeah, there is of course there is a case such as I just see the adapter button from Fian and I realize that can I use it with the dependency injection, or it probably there is a case that some people will argue that like for example in behavior patterns, there are a lot of behavior patterns like decorator, like, so there are a lot of patterns with the same function, right? So, but yeah, as Fian said, I think it's probably about pupil program. So,
okay, right.
we decide which ones to use. Okay, so it's very difficult question. Yeah.
So in the end of the day, yeah, well, you have to solve it like interpersonally, yeah, as well, yeah. And at the end of the day, it's usually doesn't, well, do or doesn't. But basically, when two of the smartest people in the room have such argument, you have to let them, actually argue about it, and because at the end of the day they will do the best for the team, right? And if they really are the smartest in the room, I believe they would be smart enough as well, to know when to stop debating which pattern to use and start working on something. All right. Next one. What's the most frequent anti-pattern that you've seen in your team? What did you do to address that? Maybe in legacy code base. From Kian Lee. All right.
Yeah, very interesting question. Well, the most frequent anti-pattern I see in my course is the big model, the fat model. Like you everything in one class, so you put own process in one class because it's easy to do it. Well, when they maybe in Ruby they have some rule like one class must have within 100 lines, and when your class is more than 100 lines, then you should be refactor it.
Okay. Okay. Based on my experience, that the two most frequent anti-buttons that I have faced is the fat model that Duke already said, that like you put everything in the model, like the logic of for example in Ruby on Rails, in you there is a decorator button that you define the logic for the view layer into a decorator class. It's kind of like the wrapper class for the model. So instead of using decorator button, a lot of engineers will probably put one of the logic code for view layer inside a model. So that could be the could become to the fat model anti-buttons. And another design button that I have faced as a God class. Like actually it's not in my team, but in the other team in my company, that I see that the controller, like the controller used to receive the request from client, right? So if you are doing the REST API, you probably have create, update, delete, and get method. But I saw that they are some class that probably have like 50 function in controller. That's probably like just controller basically do everything. I mean, so not only receive the request from client, like using REST API principle. So yeah, the God class and the fast model are the most frequent pattern, anti-patterns that I have faced. And what did you do to address that? Okay, yeah, because I already have experience about that. I already had experience in Ruby and Rails. So basically, when I see that anti-pattern, I can understand why is it bad. But yeah, that's my question. That's my answer.
Okay.
Okay, just wanna put some addition on that, right?
Mhm.
Probably like what do you do to address that, right? Especially the legacy code base, right? Where you have like a lot of anti-pattern on that. What we usually do is we perform the incremental refactoring, but I believe that before you do that, or before you suggest, for example, your manager, we should refactor this, you should like try to check, did you have a test or not, right? If you have tests, then you can just go with the refactoring. But if you don't have any tests on your code base, you should have the test first before to do the refactoring. And yeah, again, because this is some kind of like refactoring, but good thing is in the Manifold and Mekari, we usually have the engineering initiative, where we usually didn't think about we think about the product, but we also think prioritas or engineering, and we have some kind of like a space where we working on the legacy code base, how to improve that legacy code base, how to improve our performance on our system, for example. But yeah, again, the way to address that is like you do the incremental refactoring, refactor bit by bit the things that you think that this is anti-pattern, we need to update it or to change it. I think that's it.
All right. Thank you so much for your answer, guys. Okay, I think we still have time for 2 more questions. Yeah, it's such a shame because there are so many good questions here, but it's almost midnight, I believe, in Japan. So next question would be from Ignatius Rahardi. So good evening. I have 2 questions. The first one is, can we find any conflicting problems by using multiple design pattern? The second is, are there any good design pattern recommendation for front-end projects using ReactJS? Thank you.
Okay, I will answer the second question. So I'm not a front-end engineer, but in React or Vue.js, you probably use RxJS, or that's based on the observer pattern. And if you are coding front end, so you're probably using JavaScript and TypeScript, and observer pattern is kind of popular in Node.js and especially in front end, I think. So yeah, so that's a design pattern that I will recommend. And the power of observer pattern is not only about front end, but you can apply the idea of observer pattern at the architecture level. Like the PubSub pattern is kind of powerful, especially for decoupling the service. You have the publisher or producer, and on the side you have a subscriber and consumer. So yeah, just a pattern that I will recommend for front-end engineers.
Okay, so just want to have some to add what San did say that can we find any conflicting problems, right? Yeah, this is interesting, right? Just like we said, what I'm saying before, right? We can combine 2 design pattern into one functionality, but I believe that we should not add more than that, because it probably like like make your code complicated, and it's probably will lead to unmaintainable code, which you need to refactor again, and you don't want that. My advice is like probably just stick to 1 or 2 design pattern in your system or service or application, and then if you think that design pattern doesn't solve your problem because you want to going to specific, for example, like pops up pattern, you cannot have it's kind of like different, you solve different functionality, right? Different problem, then go ahead. But if you see that, but yeah, again, you should not like add more than, from my opinion, is like more than 2 is already maximum. 1 is better, because like, yeah, again, the function of design pattern is just no, the one benefit is of design pattern is like to make everyone vision or everyone knowledge in the service or the application that we maintain is same, right? Everyone knows the functionality. That's one benefit. If you add more design pattern, it probably like decrease that benefit because the code is much more complex.
Thank you, Fian.
Yeah.
Okay.
I agree with Fian.
Mhm.
So if you use 2 design pattern and you see conflict of it, then it already anti-pattern. And I think
Yeah.
that's to it.
Yeah, actually, Fian just says that 2 buttons is good enough. Actually, when I saw the code from Dirk, he used the dependency injection and started the button. I mean, it takes me a little bit time to understand, what he wants to do. I mean, so if you use the 3 or 4 design button in the same class, so that probably like makes the engineer more difficult to understand, because design pattern respond to solve problems, solve issue. So if you use a lot of design pattern at the same time as the same class, so it probably increase the complexity of the class. So it's gonna like be hard class. So yeah.
Okay. Oh, I think we're on to the next question. Perhaps this will be the last one. So from Indra Pambudi, how easily is it to recall the design pattern? There are lots of them, and some are really similar. Do you need to remember all of them in detail? Anyone would like to take this?
Yeah.
Okay.
Okay, go ahead, sir.
Okay. Okay. Do you need to remember all of them in detail? Okay, I think other speaker already said that, like Fian, he says that he probably like knows the 5 design pattern, right? So I'm thinking so. I'm around like 5, 4, 6 design pattern. The reason that I know that design pattern because I have a problem about my code, about my system. So I try to research. I try to ask other people what should I do. So other people will recommend me what kind of design pattern should I use. So my answer, you don't need to remember all of them. Like that I said before in cooking example, right? You will not learn how to cook the best ramen, how to cook the best sushi, how to make the best food, all the kind of food in the world, right? It's impossible. Like you probably will end up with like just only OOP, we have like 23 buttons, right? Not include database button, architecture button. So yeah, my answer is no. Yeah, you don't need to remember all of these buttons.
Yeah. That's what I want to say. But thank you. Yeah, yeah. Basically, you didn't need to like. Honestly, it's just like for me, it's 5. I know 23 because I researched the design pattern before this webinar, right? But most of them, this 5 design pattern, I know it because I want to solve something and I look at it, right? What the design pattern that fit with my fit to the solution to the problem itself. But yeah, as you goes along with your experience working professionally, I believe you will come up with the you will learn that design pattern naturally.
Okay.
Yeah, I think what we should start is what our problem. Then we will search for how to solve this problem, and you may find some design pattern to solve this. So learn about design pattern before we have problem. It may, I think, may be waste of time because you will forget it because you don't use it.
Okay, that's all.
Yeah.
Okay, cool. Right. I think we still have 7 minutes left, so perhaps one more question, guys.
Okay, no problem. Yeah.
Okay. I believe almost every framework implement design pattern. Even I don't know the name. My question is, if the team decide to use a framework to develop a project, do you think implementing design pattern to framework is a good idea? I've met the team who got confused because of the customized framework to some pattern by previous developer from Onesio Stamba. Interesting.
Okay. Okay, I will go first. Oh, okay. I'm working at a Nest.js framework. If you have not heard about it, it's a TypeScript framework, and it's basically same with the Java Spring. And in that framework, we have the repository button. So basically, so repository button is you put all of the code of accessing to database in that class. So that class will be responsible for handling, some database query, something like that. And if you want to try apply that button in Ruby on Rails, I mean, it doesn't make any sense, right? Because we already have active records, right? You can easily handling some database logic by active record without implement the repository button. So I think its framework have some principle that you should follow that. And each framework have totally different kind of design pattern. So if you already choose the pattern that you want to follow, so you should follow the principle of that framework. That's based on my experience. And the point is that you probably the engineer skill is probably not good as enough like Rails contributor. So by modifying Rails code is the bad idea. I mean, because you probably not good enough as a Rails contributor. So you should follow their design. So that's my experience.
Yeah.
Actually, I disagree with you. Well,
really?
Yeah.
Okay.
Interesting.
So, well, if the framework implements some design pattern, we should use it and we should not reinvent the wheel. But if framework do not solve our problem, so maybe use some other device. So we may use other design pattern to solve its problem. For example, in Rails, you can use decorator pattern to decorate the complete of view. Yeah.
I see. But I'm interested in this, to follow up by your answer, Duke. In that case, wouldn't it be better to choose another framework altogether rather than forcing your own design pattern into a framework that actually made to use another?
Okay. So okay, as I said before, that all of decision in software engineering is based on context, right? You should consider about the refactoring cost and the development cost.
Mhm.
So if you just want to use some pattern and you switch all of the frameworks, that sound like ridiculous for me. Like you need to refactoring all of the code to the new framework. So yeah, so I think you should consider about the refactoring cost and development cost to make a decision. I mean, without design button, I mean, so applications still work, right? I mean, it's still working, even so code is messed. So yeah, I think, yeah, that's my answer for the questions.
Anybody else want to add a statement?
Yeah, I think I'm very interested with the last statement, right? Met the team that who got confused because customized framework to some kind of like a pattern by previous developer. I think this is why probably, yeah, I think almost all of us is have experience, like given the code that wrote by somebody else, but that person doesn't tell anything about that code, right? And we got confused, right? I think this probably can be prevent in the future, for example, probably. But if but we as developers sometimes like already know the like the basic pattern, like we know what is the pattern is, right? We, unless the pattern is not like anti-pattern or like some weird things, I believe we can understand it one by one, right? But the decision to like do we still maintain it, or like do we change it to another design pattern, is just like up to you. If you it's just basically up to you. Again, you need to consider the cost of the refactor, right? Because like we develop something for the business, right? Sometimes that's one of the missing idea. We as a developer, right? We want to something perfect, but doing that something perfect, it's probably costs much more time and doesn't bring any value. I think like we as developer need to remind ourselves that like, okay, this is bad, but I could fix it bit one bit, not like spend my whole week to fix it, right?
Okay. All right. I really hate to interrupt a fiery discussion, you know, but I think it's time we close the webinar. Yeah. Okay. Perhaps I can summarize the talking point. Right. So yeah, the talking points from our discussion today is about using or utilizing design patterns effectively. So basically, design patterns comes from the need to produce a reusable solution to a common problem, right? And it's basically a tools that you can you need to gauge the trade-off to be able to use it. There are many benefits of using such pattern. Basically, improve communication, make code easier to maintain, and improve performance. So basically, there are do and don'ts of design pattern. So basically, you have to understand the problem and be careful of the anti-patterns, right? Okay, next. Basically, at the end of the day, when we want to decide which design patterns do we want to use, so first one is to base it on the programming language that you guys want to use. Some programming language is better suited to use a particular patterns than others. The testability of the design pattern itself, yeah, basically whether it's easy to test or not on your on the application that you want to build. Performance output, whether that solution will make it easier to maintain the software, the performance impact of adopting such pattern, how long does it take to adopt that pattern itself, you know, the refactoring time, implementation, etc. And basically, decided on your current team situation, yeah, resources and costs, etc. So yeah, it's been a very interesting discussion. Thank you so much, everyone, the attendees, the speakers. I've had a lot of fun talking with you guys until this late and night. Thank you so much for sparing your time to well, have this discussion, especially those who are in Japan. You know, it's about 10 p.m.
10 p.m.
Yeah. Okay.
10 p.m. in Japan.
Cool. I guess then see you on the next Agile Ambition. Okay. Thank you, guys.
Thank you.
See you guys.
Mhm.
Bye bye.